All right, so the next lesson in this chapter is solving these systems using substitution. What it comes down to is it's a very simple process, and there's a time to use it and a time not to use it, okay? But here's the gist. Our goal is still, right? Our goal is to find the ordered pair that makes all the equations true. And when we solve these algebraically, we're going to add a second goal to this, and that's to break it down, break the system down to one equation with one variable. Okay, so my first step here when we do this is to solve one equation for one variable. And that can differ, right? You can either solve for x or you can solve for y. Once we do that, we're going to substitute one equation into the other, right? And solve for the remaining variable. Okay, so if we solve for y, it's a hypothetical, right, value for that y. We'll plug it into the other equation. Or we'll solve for x and do the same thing. Once we have the value of one variable, right, we take that value and we plug it back in to find the other variable. Okay, so the key here is to work as fast as to work as efficiently as possible. Work smarter, not harder, is the idea of this method. Okay, so if you have to pause the video to write that down, pause it, and I'm going to move on. So what I like to do is create a t-chart. Okay, I like to put one equation on one side and the other equation on the other side. Okay, now what the goal is here is I look at the two equations. Do I have one variable by itself? And the answer to that is yes, right? I have this equation already has y by itself. Okay, so what I'm going to do is in the other equation, everywhere I see a y, I'm going to replace it with this value, 3x plus 2. So what do I have here? I have x plus 2. In parentheses, I'm going to put my 3x plus 2, right, equals 11. Now, if you notice, now this equation has one variable and one equation, and I can solve for that variable, which is x. I bring down the x, plus I distribute the 2. 2 times 3x is 6x. 2 times 2 is 4, equals 11. Now, when I combine like terms here, I get 7x plus 4 equals 11. Now again, my steps to solving for x, I subtract 4 since it's positive 4. Subtract 4. 7x equals 7. Divide by 7, x is equal to 1. I have my x coordinate of my solution, which is 1. Now I have to find y, so I go back up here. I plug that x value in. 3 times x is 1, so 3 times 1 plus 2 would give me 3 plus 2, which is 5. Now, my solution would be 1, 5. X is 1, y is 5. Okay, so notice the idea. Work smarter, not harder. Find the easiest variable to, plug in, solve for it, go back, plug it back in. So the next one, if I look at this, I create my t-chart, right? I'm going to put one equation up here. I'm going to put the other equation over here. So 4x plus 6y equals 4. Now, I look at the two equations and I say, what variable is the easiest to get by itself, right? Meaning, what's the easiest way to solve for 1? And if I look, x in this equation is the easiest to get by itself because all I have to do is add 2y to both sides. So I take that equation and I'm going to go ahead and solve for for x. I'm going to add 2y to both sides and I get x equals 2y, so it's positive 2y, and then I bring down the minus 6. Now, everywhere I see an x in the other equation, I'm going to substitute that in. So I'm going to get 4. Oh, what happened there? Excuse that. 4, and then in that x goes out, and I'm going to put the value of x from the other side, 2y minus 6 in its place. Then I still have to bring down the plus 6y equals 4. So now my next step is to go ahead and distribute the 4. 4 times 2y is 8y. 4 times negative 6 is minus 24. Then I have the plus 6y equals 4. So now, right away, I combine my like terms. 8y plus 6y is 14y. Minus 24 is equal to 4. So to get y by itself, I add 24 to both sides. 14y equals 28. Now to get y by itself, I would divide by 14 and y is equal to 2. Now that I have y by itself, right, now I can take that value, come back to the other equation, right? So I have x equals, everywhere I see a y in here now, I'm going to plug it in with that value. So 2 times 2 minus 6 equals 4 minus 6, x is negative 2. So my ordered pair solution to this system would be x is negative 2, y is positive 2. And this is my answer. Okay? So as we look at the examples they give you, right? This is the curriculum. The first one, if I go over here, I'm going to put y equals 2x plus 7 and x equals 9. The nice part about this type of problem, you already know the value of one variable, don't you? What's the only value of x that can make this equation true? 9. If I know that value, all I do is I come back over here, and everywhere I see an x, I replace it with a 9, and find my y value. 2 times 9 is 18, plus 7, y is 25. So my ordered pair solution for number 1, x is 9, y is 25. Okay? Pause the video and try number 2 on your own. Okay, number 2 works the same way, right? I put my two equations up here, right? And again, if I look, isn't x already by itself? And is there anything to even like solve for here? No, the only value of x that'll make that true is negative 3. So all I have to do is come over here. Everywhere I see an x, I replace it with negative 3, right? So 4 times negative 3 is negative 12, minus 5 is negative 17. So my ordered pair solution here is negative 3, negative 17. Okay? So the next one. This is where it gets maybe a little complicated, but 3 and 4 are the same problem with just different numbers, right? So let's go through this one. All right, I put the two equations up here. Now, It doesn't matter. You see how this is y equals? What is the value of this y value? What is this y value? X plus 6. So basically what I'm going to do is in the other equation, everywhere I see a y, I'm going to replace it with x plus 6. So this y becomes x plus 6, then equals this side is 2x plus 1. Notice I accomplished my goal here. I've narrowed it down to one equation with one variable. Now I have to solve for x. I subtract 2x from both sides. I subtract 6 from both sides. And negative 1x equals negative 5. Now to get x by itself, I divide by negative 1 and I solve for x. Right? Now that I have x, it's easy. I can take that value and I can plug it into either one of the equations. It doesn't matter. It's a lot easier just to jump to the other side and say y is equal to, if x is 5, replace x with 5, so 5 plus 6 gives me 11. My ordered pair solution here now, x is 5, y is 11. So do me a favor, pause the video, come back and check number 4. All right, for number 4, we have y equals x plus 2. Then the other one is y equals 3x plus 4. So again, if I look, both equations are solved for y. So I'm going to take this value of y and plug it in for y over here. So I see the y, I kick it out, and I replace it with x plus 2 equals, I have my 3x plus 4. Now I can take this equation and solve for what variable? X. So I subtract 3x, I subtract 2, x minus 3x is negative 2x. You have to be careful with signs here, right? 4 minus 2 is 2. And now, when I divide by negative 2, x is equal to negative 1. Once I have my x value, I come over here, I plug that value in. Replace x with its value, negative 1 plus 2. So y is equal to negative 1 plus 2 is 1. Therefore, my ordered pair solution is negative 1, 1. Okay. Now, number 5 is the same way. I'll go through it again just so you have another example. Y equals 6x plus 2. Y equals 3x plus 11. So I'm going to take this value of y, plug it in here. So I would get 6x plus 2 equals 3x plus 11. I'm going to go ahead and solve for x here. Subtract 3x, subtract 2, and I would get 3x equals 9. When I divide by 3, I would get x equals 3. Now, once I get x equals 3, I come back over here. 6 times 3 plus 2 gives me 18 plus 2, which is 20. All right. And again, I know I'm going through fast here, but to get through all these problems in a timely manner, I would hope you can pause the video and go back and look at some. Now, the next one, all right, number 6. I'm going to write my two equations up here. Y minus 5x equals 7. Then I'm going to write 3x minus y equals 9. Now, if I look at these two equations, I don't have either of them solved for a variable. So I want to look and determine what's the easiest variable to get by itself. And in this case, y in this side is easy to get by itself. How do I do that? Well, if I bring that down here, equals 7. To get rid of the 5x, all I have to do is add 5x. So I would get y equals positive 5x plus 7. Now that I have y by itself, this is the value of y I'm going to substitute in here. So I bring down my 3x minus, everywhere I see a y, I'm going to replace it with 5x plus 7. And I generally like to do that using parentheses, and that will equal 9. Now this solving is the critical part, right? And if I look at it, I bring down to 3x, but I have to distribute this negative. A negative times a positive gives me minus 5x. A negative times a positive gives me minus 7 equals 9. Now I have to combine like terms here. 3x minus 5x gives me negative 2x, right? Minus 7 equals 9. I'm going to add the 7. Negative 2x equals 16. Divide by negative 2, x equals negative 8. Okay, now that I have x, all I do is jump back over here. Wherever I see an x, I substitute it in. Negative 5 times 8 plus 7 will give me negative 40 plus 7, which gives me negative 33. So this ordered pair solution will be x is negative 8, y is negative 33. If I was to plug that ordered pair back in up there, that is the ordered pair that would make both of these equations true. Okay, now I'm going to erase some of this to give me more room, right? But the next one, right? I look here, I'm going to write my two equations up here. Y minus 2x equals 3. Then negative x equals y minus 9. So there's actually two variables that are easy to solve for here. I prefer one over another, right? But I think it's easier to solve for y in the first equation, right? So when I look at this, I think it's much easier to take y minus 2x equals 3 and solve for y. How do I get rid of negative 2x? I add it to both sides. I get y equals 2x plus 3. Now, in the other equation, everywhere I see a y, I'm going to replace it with 2x plus 3. So, I bring down my negative x equals, I'm going to take that y out, replace it with 2x plus 3, and then I still have my minus 9. So now, I'm going to go ahead and solve this. Subtract 2x, subtract 2x. If I combine these terms on one side, that gives me negative 3x, 2x disappears, equals 3 minus 9 is negative 6. I'm going to divide both sides by negative 3, and I get x is positive 2. Now that I have x, I come back over here. Wherever I see an x, I replace it with a 2. So I get 4 plus 3, which is 7. Now, my ordered pair solution, 2, 7. Now, the last example here is probably the most complicated. So we have 2y minus 10x equals 12. 2y minus 2x equals 20. Now, either of these equations are easy to solve for. Okay, personally, right, I'm going to look at it one of two ways. I can solve easily for y in the first one or easy for x in the second one, right? So looking at this, let's just go ahead and take this equation and solve for y. First thing I want to do to get y by itself, I'm going to add 10x. It's going to give me 2y equals 10x plus 12. To get rid of that 2, I'm going to divide everything by 2. And I get y equals 5x plus 6. I'm going to take this value of y everywhere over here. I'm going to kick y out, replace it with its value, 5x plus 6, minus 2x equals 20. I'm going to distribute the 2. I get 10x plus 12 minus 2x equals 20, I can combine these like terms. 10x minus 2x is 8x plus 12 equals 20. Now to solve for x, I subtract 12. 8x equals 8. Divide by 8, and x would equal 1. If x is 1, I come over here. 5 times 1 plus 6 will give me 11. And that would give me 1 comma 11. All right. Now, the last word problem, Lauren and Minky, or whatever that name come from, are in a bike race. Lauren bikes at 18 miles an hour. Minky bikes at 12 miles per hour and has a 6-mile head start. Write a system of equations that represents each person's distance. Let D represent the distance and T represent the time. So the one thing you need to know is distance is equal to rate times time, isn't it? So it's basically your speed times time. So when I look at Lauren, her distance, right, is going to be, what is her rate? Her rate is 18 miles an hour, so 18 times T. Minky bikes 12 miles an hour, but she already drove her road 6 miles. So her distance would be 12T, 12 times the number of hours, plus the 6 miles she already drove. Now, as you can see, Lauren is driving faster, so eventually it'll catch up. So how fast will it take her to catch up? Well, if we solve this system, right, we have D equals 18T, D equals 12T plus 6. So what I'm going to do is take this dt, or D equals 18T. So I'm going to take the value of D, plug it in here. 18T equals 12T plus 6. Now, from there, I'm going to subtract 12T. I'm going to get 6T equals 6. And if I divide by 6, T would equal 1. So Lauren catches up after 1 hour. All right. So go ahead, do the quiz. Text me when you're done. And again, if you're doing bad on the quiz, stop and we'll conference.